Okay guys, I just checked. Actually, I've been looking at some of your work on the phone, and several of you have done 13 to 18, so obviously I'm going to assume that's what I've given you to do, questions 13 to 18 in the introduction section of Simultaneous Equations. It's all there in your PDF. So the suggestion is, so question 13. This is where this is going to come in. We're not, instead of writing out the equations, I suggested, and you saw I got into a bit of a muddle in class, writing out the equations 3 times. It's an awful lot of work. We're going to take the ability to just look at what values give, and if it doesn't work, rub it out. We're going to take kind of a cursory view, a quick view, and when we know something doesn't work, we'll get rid of it and we'll use the rubber to rub things out. I'm doing the exact same up here with my marker. So question 13, I'm only going to write it out once, and I'll again take the approach. Now another approach, and you're going to say, well, you see, if you're not open-minded, if you're not open to try new things that really mean the same as the other things, then we won't together discover the best, what we all consider the best way. So it's always important not to get too upset if one time I'm writing, say, the 2 double braces, the equation goes here and the equation goes here, and for me to say, well, maybe we're mixing them up and there's a lot of lines and it's very hard to tell them apart. So I'm thinking maybe it would be nice to take the second line on the right and the first line, the first equation on the left. And I think it might be easier. I want you as maths learners to be prepared, despite the fact you might be having success, to improve your mechanisms, to improve your algorithms. No matter who your teacher is, me or someone else in the future, to be able to go, well, I can fine-tune that and I can lay it out differently on the copybook, to a way that suits me and my brain. So here we go at 13, and this is the way I think it might be best to do it. So first off, it's a mess because it's not laid out the way we expect it to be laid out. So we'll deal with that on the board here. I'm not going to do it in my head. Of course, I could possibly do it in my head, but that wouldn't be fair on you. So I'll write that. This is the way it's written in the book. Okay, now the problem with that is that it's not in what we call standard form. So equations can be implicit, so you can take a note now. If equations can be implicit or explicit. Now these are big concepts, but what it means, implicit means basically y is on its own. And explicit means y is not on its own, and if it's not on its own, if it's explicit, the constant will be on its own. And the standard way of laying out an explicit linear equation is to have the x term plus the y term. And you can say, but sometimes it's minus, but then this would be a negative y term. So it'd be always have the x term first, then the y term, and then the constant. So you pause the video now and take that down. So and this is called some sort of standard form. You're going to hear this over and over again in different parts of your maths. So if we want it in standard explicit form, which we do, then we're going to put the x terms, then the y terms equal a constant by rearranging into an equivalent equation. We had that idea last week. An equivalent equation is an equation with the exact same solution. Well, in this case, an equivalent equation of x and y is with the exact same whole load of solutions. But when you do equivalence on both, you're not going to ruin your simultaneous solution. Okay. So now, using some of the phrases and the terms I've just given you, I'm going to speak slowly through what I'm doing here. I'm going to take the top one and write it on the left. I'm going to take the bottom one, rearrange it to an equivalent equation in both cases, and I'm going to split my board. And you split your question left and right. So that's not a very good split on my board. You're at a funny perspective coming from the side. I think that works nicely because I don't have to turn around to you like in a normal class. There are people over there, people here. You're just in the right place. So split the board, and on my left hand side I'm expecting x terms. Now I have a negative 2x, and remember this is on the right hand side, or HS, okay, and this is the left hand side. So I'm taking my, and now listen carefully for my word here, I'm taking my x variable term, my variable term in x, and I'm bringing him across to the other side. So I'm using the additive property of equivalence, meaning I can add 2x to both sides, but we have a shortcut for that, which is to change sign. So he becomes 2x over here. I'm leaving him alone because he's a constant, he wants to be on the right. And I'm leaving him alone because he's a y term and he wants to be on the left. So he's going like that. I put him in there and the 1 stays there. Okay, and I said I'm not going to write this one underneath because it's going to be like confusing. I'm going to put him over here. Okay, our system is evolving. Now the x wants to come back, I'll make it minus x. Okay, just like at the previous time. The y is in the right place, I'll make it plus 2y. And the 11 this time is in the wrong place, is in the wrong side, he's on the left side. I'm going to move him over to the right side. Again, I'm going to use what's called the subtractive property of equivalence, which means I can subtract 11 from both sides, and I hold on, and I conserve the equivalence. The equations are the same, they have the same solutions. So I'm taking the 11 across and turning it into minus 11. I'm just giving you fancy words and I'll write them out. Fancy words for change side, change sign. If you're taking a plus term over to the other side, you're using the subtractive property of equivalence. Because you have something like A plus B equals C, and let's take B away from both sides. A is equal to C minus B. I haven't changed anything, the equation is still the same equation. Now by the same token, let's say you have G minus H equals F, and you went G equals F plus H. If you bring a negative term across here, it's like adding both sides. So instead of saying the subtractive property of equivalence, here you talk about the additive property of equivalence. So in other words, if a minus term is going across, you can call it the additive property. Now if all of this is going over your head, it's okay as long as you understand the idea of change side, change sign. Additive property of equivalence. Alright, where are we? Well, I think we've written down the two formula. And then we have 3 suggestions. Now I need some space. And this is where if you have plenty of paper, and you generally do have, even when you're answering the questions, and again you have your rubber and your pencil, and going, well, I wish I'd given myself some room to put the various pairs. Now what I'll do, so you could always kind of restart your question and write, and it doesn't take awful long to write where you're at already. But what I'll do is just wipe that, because I'm on a video. You can always go back to the back of the video to see that again anyway. And now I'm going to write out my candidate pairs. And I'm doing question 13 now. So my candidate pairs are 1/2, 0, 5, negative 3, and 11, 0. I'm not going to put the braces on either side because that will only take me further away from where I want to be. And neither am I going to, you see, you could start saying, well, sorry, you have to put your braces on both of these. And you do, but let's see how we're doing here. If we could say, well, we'll put the braces on at this point. Let's see how you get on here with this. 2 times 1/2, there's my braces, plus 3 times 0, there's my braces, and you won't ever have braces in the constant, because he's already quite happy. Okay, now that's 2 over 2 plus 0, which is equal to 1. I'm pretty sure I can tell that now. I mean, if you want, you can go 1 equals 1. Maybe that really makes you feel like, well, you can't argue with it. 2 over 2 is 1. If you want to kind of say, well, we're putting in loads of steps, preparing for the future when we're always going to have lots of steps. Good. And preparing for catering for the people who aren't as smart as you, remember. There may be people, if you went to an Aborigine tribe, you know, in the Amazon, they might get this, or they may not get this. So be prepared to break it down into its basic elements and keep it simple. Cool. Now, this is no good unless it works here too. So a half will go here. Now it's minus, and this is where the power of care of substitution and the brackets comes in. Subtract half is x plus 2 times 0. And we're not getting 11, okay? That is not. And this is important. So instead of having to write the word false, you can just write the word, this is definitely not minus 11. Now where that leaves us in terms of substitution is I need space. I need to use this and maybe this. But again, I'm possibly at an advantage. And we can just do that. Do that too. You can't really, because you do want to leave the work there for the examiner. I'm leaving it in the form of video. And I can also make a video for your homework and send it and put it up on stream. It'd be brilliant if you did. You don't have to have a whiteboard. You can just get a way to hold your phone over your sheet and start recording. I'd learn an awful lot, and I will look at one or two if you do that. Just don't put it on YouTube. Don't put it anywhere except within the school system, which is streamed in Office 365. Okay, we got 5 and negative 3, so he's going to be coming in here to us like this. 2 times 5 plus 3 times negative 3 might be equal to negative 1. Might be equal to 1. And that's 10 take away 9, which is indeed equal to 1. And somehow we can kind of make these really these are really truly, maybe. Now I'm thinking, that's a reason why to leave the squiggle until you're certain. Okay, that's a reason maybe when I said, oh, I'll let you put in the equals, but really it helps not to. Because then what you can do is, once you've seen that it's true, once you can calculate, once you got down to a level that you can calculate that it's true, then saying that is a statement. Just like earlier, you saying 9 is not equal to 10 is a statement. You don't then have to write the word true. Certainly write it if you want to, but you could decide, because of the squiggle, you don't ever have to use true and false. You either use equals or not equals at the end. Okay, but it has to be true on the right hand side as well. So we've minus 5 plus double negative 3, squiggle, negative 11. It's a little bit, the squiggle means it's either, it could be equals or it could be not equals, we're not too sure. And the jury is out, we don't know yet. That's what the squiggle means. Squiggle, kind of cool, funny word, right? So we've got negative 5, that's calculating that. The subtraction of 5 is the same as the integer negative 5, or it's the same as the operation take away 5. Or start with minus 5 on the number line. We can go on forever talking about this. Plus 2 times negative 3 is negative 6, and that is indeed equal to negative 11. And now we know the answer. Because this is true. Maybe you want to emphasize it and say, yeah, fine, but surely you want to write true twice, just to make yourself really certain. And that means this middle one was true, was the candidate, was the answer. So what I'm going to take now a note of is do up a table of the answers, so we can verify them really quickly and from a summary point of view. 13, the answer was B. Number 14. Now, first write it the way it appeared. They're not great braces. I really wanted to improve my brace. To practice. So the 14, the system begins like this. It's not in standard form. It is explicit, it's not implicit, it doesn't have y on its own. Oh, it does in that case actually. But that's not something we're aiming for. Now you could, you could say, well, why not? Why not just fill in and see your day through? Why do you have to make it explicit? And you're technically speaking, you don't. It's just maybe a good habit for you at this stage. And in the interest of teaching you how maths works, let's leave them the way they are. Let's say, fine, this is on the right. And it has to be come through, and this is on the left. But you see already, I'm getting mixed up on that, but okay. Okay, it's a bad idea. It's a bad idea because you're going to have to kind of keep track, and a pattern is going to break, and you're going to end up, you're going to have to be concentrated an awful lot more in the long run. Maybe just writing them down was easy, so I'm going to change my mind. It's a bad habit. We're going to stick to our guns. I'm going to say make them both explicit. So I'm going to make the top one explicit. I like it starts with the 4x. I'm going to use the subtractive property of equivalence, meaning I can subtract y from both sides. And I'm going to use the subtractive property of equivalence again on the 9. For you, you said, come on, stop talking nonsense. You change the y to the left and you change the 9 to the right. But that doesn't really make sense in maths language. I subtracted y from both sides and I subtracted 9 from both sides. And we cut through all of that and kind of cheat a little bit.